Okay, looking at one-step equations, say 3x equals 18. You can divide both sides by 3. Okay, you get 3x over 3 equals 18 over 3. Now, open math is going to say, okay, now you cancel the 3's as if people know how to cancel. People don't know how to cancel. 98% of the people starting my pre-calculus classes over the last several years would cancel this the way I've done it, and it's totally wrong. Okay? Canceling is not just finding the same number up here and crossing them out. Okay? Canceling occurs because you can factor out 3 over 3. Certainly, 3 over 3 times x over 1 equals 3x over 3. Okay? So this is equal to this. 3 over 3 is 1. So now I have 1 times x over 1. X over 1 is x. 1 times x is x, and now x is 6. This is shorthand for this. Now there's a rule, you can cancel factors. Okay, well that's what I've done here. I said that this thing is a factor. And now, if you want to cancel at that point, it's okay. So, be sure when you cancel, you're canceling factors. Very important. Okay, x plus 7 equals -5, so we can subtract 7 from both sides. 7 minus 7 is 0. X plus 0 is x. Of course, -5 minus 7 is -12, so there's our result. Okay, one other example. Say you got x over 4 equals 8. What do you do here? You always, when you have an equation that has a denominator, you multiply both sides by the denominator, okay? If you've got a bunch of denominators, you multiply both sides by the common denominator. That's worth noting. It'll save you a lot of trouble later because you're going to see a lot of equations in a pre-calculus course that are much, much easier to solve if you remember to do that. Okay? So anyway, you do 4 times x over 4 equals 4 times 8. And then there are some steps. Maybe you think you can cancel this with this, and you can. Okay? But that's because you can express this as 4 over 4 times x over 1. And the 4 over 4 gives you 1, and x over 1 is x. And you end up with x. So I've got some dots here. There's some stuff you have to think about to make sure you're not messing it up. And you get x equals 32. Okay? So one-step equations, pretty straightforward. Okay? Now you're going to get the open math on that. Okay. That's that topic for now. Now, the next topic is geometry. And really, it's just area and perimeter. Or not going to finish it, but it's circumference. Okay, just a distance around something. And I think everybody is familiar with this. So perimeter is pretty easy if you have a polygon. If you have something that's formed from straight lines, a closed figure that's made up by straight lines. If you know the length of each of those straight lines, you just add them up, right? Okay? So if I have something that looks like this, and you won't see anything that looks like this in this assignment, but there's no reason you couldn't do it. And if these lengths are 5, 6, 5, 3, 4, 4, and 5, then the perimeter is 6 plus 5 plus 3 plus 4 plus 4 plus 5 plus 5 And that equals whatever you get when you add that up. You got 3 5s, that's 15, 23, 26, 32, if I did it right. Okay? What's the area? You can't tell from this picture. If I've got a bunch of boards with one nail through each place where they're joined in a shape like this, I can pull that shape apart or compress it, I can move it. It's not a triangle. Anything bigger than a triangle, you can deform it without changing the length of the sides. So there's no formula, general formula for the area of anything bigger than a triangle unless you put some restrictions on it, okay? Now, if I know all the angles between these, then I can figure it out. But that's more than I'm going to ask in this course, okay? That's a pain. Okay. Now, if you have a triangle, still you have to know something about the triangle. There's an altitude in this triangle. First you decide which side you want to be the base. So I'll call this the base. Then the altitude goes from the vertex opposite the base, the corner of the triangle opposite this thing. These are called adjacent. They're part of the base. The base hits them. It's adjacent to the base. This is opposite the base. Then you go from the vertex down to the base at a right angle. Then the length of this thing is the altitude. So I'll use a little color to emphasize that. And an altitude goes from the vertex down to the base, or down to the opposite side at a right angle. Okay? I don't want to say too much about this one, but there's a definition of altitude and base. And then the area is 1/2 the base times the altitude. Now this is because you could take a copy of this triangle and paste it on and form a parallelogram. So, parallelogram well, an altitude still goes from a vertex to a base. Any side can be the base. So I'm going to say we're going to let this side be the base. I could have chosen this one, but I choose this one. Okay? And then we take the vertex that doesn't touch the base. Could be this vertex or this vertex, but here we're going to do this one. And there's your altitude. Now, you don't need to understand what I'm about to say, but just to tell you there's a simple reason for the formula. for the formula. Parallelograms just choke me up. I gotta go in here and cough. Allergies. Can't do much about it. Okay, now, again. If I take a pair of scissors, I can slice this little triangle off. And then I can take that triangle and flip it and glue it up here. Okay? And I'm going to get a rectangle. So I can cut and paste. I can get a rectangle. And the dimensions of that rectangle would be base and altitude. The width would be the base, and the length would be the altitude side. Okay? I'm not going to picture that, and I'm not going to picture this right now. But you could put two of these together to make a parallelogram. You can cut this thing here, move this thing up here to the right place, just flip it over, tack it on there, and it becomes a rectangle. And we know that the area of a rectangle is just length times width. Okay, now, we also got to know about circles. And they're trapezoids, so I'll let you read about those. Kind of a bad looking circle. Okay, well, I think everybody knows what the radius of the circle is. Center out to the circle. Circumference is 2 pi r. Area is pi r squared. Maybe a little hard to keep these straight because they have exactly the same symbols, just in different places. You got a 2, you got a pi, you got an r. In this one, the 2's up here, and then the pi r is here. Here, the 2's out front of the pi r. How are you going to keep that straight? Well, let's say r is measured in inches. Okay? Now, what would you then actually measure the circumference in? Inches, right? Or if r is in feet, you can measure your circumference in feet. Well, 2 pi r, if r is in feet, then 2 pi r is in feet. Because 2 pi doesn't carry any dimensions, right? There are no units to it, okay? However, pi r squared would be in what dimensions? Well, if r is in feet, then r squared is in feet squared, which is square feet. You don't measure distance in square feet, you don't measure area in feet. Okay? So two pi hours in feet, that's a distance in circumference. Is a distance. This is in square feet because you're squaring R, you're squaring the feet. And that measures area. So there's a reason you want to use pi r squared for area and 2 pi r for feet. Okay? Now I could derive this stuff, but you don't want to see that. That's enough of an explanation at this point. You get into more advanced course and maybe understand why the area is pi r squared, circumference is 2 pi r. I could explain it to you now, you probably understand it, it would take time. We don't need to do that at this point. Okay?